Hi, I am Zhou Zhilin. I'm from Wuhan University and major in finance. I had a quite challenging period when I served as a quantitative analyst in the product department of Futu Network during my junior summer vacation. I was responsible for deep learning stock selection strategy. Although I've taken lots of online courses about deep learning, it was the first time that I was faced with a practical project. In pursuit of innovation and better return, I needed to break a new path by using complex and advanced models. Therefore, I made numerous explorations on CSDN and GitHub, and experimented with cutting-edge models such as generative adversarial network and variational autoencoder. I knew nothing about these models before, but gradually I found out that they are consisted of more basic forms of network, and they modify their loss function and iteration to suit their function. Then I could build them more on Keras after trial and error. Under instruction of my leader, I finally chose LSTM because it had excellent predictive effect on time series. I further improved the accuracy by optimizing hyperparameters via Bayesian optimization that needs few iterations. The model had excellent backtesting performance in A-share market. Because the model required tremendous computation, that is, I needed to predict the price movements of 300 stocks. I needed to speed it up by applying parallel computation and GPU server. And I was a novice to these fields, but I could gradually find my way out after consulting lots of materials as well as trial and error. The way to organize the parallel computational graph was quite tricky, because LSTM is a kind of recursive neural network that cannot be accelerated by simply parallel computing on several GPUs. That is, one LSTM is better to be trained on a single GPU. While it was so difficult to control which LSTM to be trained on which GPU, while guaranteeing that each GPU is assigned with equal amounts of workload so that all GPUs could be utilized at the same time. The solution was I equally divided 300 stocks into 8 batches, since my server had 8 CPUs, and now I had 8 processes. Then each batch was processed sequentially, and the 8 processes were parallel computed. I also limited the maximum usage of GPU of each process. Finally, I fully utilized all GPUs, and their usage were all above 80%, and accelerated the model by 10 times. The project was so inclusive that I developed deep understanding about how to use deep learning to develop strategies and how to improve the accuracy and accelerate the training. And I know how to evaluate the performance of the strategy by backtesting and find room to improve. That's what quantitative finance does. Good ideas, advanced models, fast processing, and continuous improvement. CS and AI play big roles in this field. I'm sure it had me well prepared for my career in quantitative finance, for I'm familiar with many aspects of quant.